Okay, good afternoon, class. So, you guys had exercise 5 to do, and it was on page 102. You had to do the odd numbers of the whole exercise, not of number 1. So the first question says, prove the identities by using mostly the double angle identity. Okay. So, which side is more complex, the left hand side or right hand side? The right hand side. Okay, let's go with the right hand side. The RHS, right hand side, is equal to, what can happen there? Difference of 2 squares. So it's going to be cos squared x plus sine squared x times cos squared x minus sine squared x. So what's cos squared x plus sine squared x? 1. So it becomes 1. And what is cos 2x minus sine? Cos squared x minus sine squared x? Cos 2x. Which is equal to the left hand side. You all okay with that? Let's look at the next one. 1.3. There I must just write the identity there. Cos 2x or alpha is 2 cos squared alpha minus 1. 1 minus 2 sine squared alpha. Cos squared alpha minus sine squared alpha. And the other one, which is sine 2 alpha, is 2 sine alpha. Okay. So what can happen here is that one is a definite. Not so. You all agree that left hand side is more complex to work with. Okay? We're always the one of choice. So it's going to be 2 sine x plus 2 sine x cos x. Not so. Over, that can be one of 3. I'm going to come now back to that one. You can choose at this point any one of those 3. Okay? Just choosing the right one will give you one step less. You understand? So I always just leave it for the next step. For once I know exactly which one of the 3. If at the end I don't know, then I write any one. And then work with it. Okay? People, what can be done in the numerator? You take out sine x is a common factor. What am I left with? 1 plus 2 cos x. Do we know already which one to choose? The one dealing with cos. Okay? So that would be 1 plus cos x plus cos squared x minus 1. Or 2 cos squared x minus 1. Okay? Or if you said you want to get rid of the 1, then I would have chosen that one anyway. Okay? So, what can happen in the denominator? We can take out cos x as a common factor. I'm then left 1 plus 2 cos x. Now what? You can cancel. So I'm left with sine over cos, which is tan of x, which is equal to the right hand side of the equal sign. Okay? Any problems there? Any problems there, people? No? Let's take this off. 1.5. So which side is the side of choice that we're going to work with? The left hand side. Okay, so cos, which one of the 3 we're going to choose then? Sorry? 1 minus 2 sine squared x. Why? If you want to get rid of the 1, yeah, you're right. So it's 1 minus 2 sine squared x. Why? Because you want to get rid of the 1. So that cancels, not so? But negative times a negative is a positive. Don't forget that. Somebody made that mistake earlier on. When I checked your work and everybody did their work, no? Nice. Wishful thinking. So that's going to give us 1 minus 1 plus 2 sine squared x over 2 sine x cos x. That cancels. So I'm left with 2 sine squared x over 2 sine x cos x. Not so? So the 2's cancel and that sine cancel one of those. It leaves you with sine x over cos x, which is equal to tan x, which is equal to the 9. Okay, you guys understand? Alright, 1.7. Of course, the left hand side expansion is better, easier than reducing from tan, working in the other direction. Not impossible, but it's going to be easier. Okay. Okay, so what we're going to change cos 2x to? Which one are we going to choose? The one that you can cancel the 1 by, not so? And which one would that be in the numerator? Sorry? 1 minus 2 sine squared x. In the denominator? 2 cos squared x minus 1. I didn't need the bracket in the denominator. Could I cancel this here? You all agree with that?
No, sir.
No? Why? There's pluses between. It's more than one term in the numerator and denominator split. So we're going to get rid of the bracket, so it's 1 minus 1 plus 2 sine squared x plus 2 sine x cos x over 1 plus 2 cos squared x minus 1 plus 2 sine x cos x. Now what? Cancel. 1's cancel. So what am I left with on top is 2 sine squared x plus 2 sine x cos x. What's common there? 2 sine x. What are we left with? Sine x plus cos x over. The denominator again, that cancels. What are we left with? We're left with 2 cos squared x plus 2 sine x cos x. So 2 cos x is common. I'm left with cos x plus sine. So what happens now? 2's cancels. Sine x plus cos x cancels. So we're left with sine over cos, which is tan of x, which is equal to the right hand side. Okay. Last one. (1.9). Of course, the left hand side we're going to work with first. We might work both sides here, which is going to give us what can happen to cos x plus sine x all squared? You can multiply that twice, not so? So it's going to become cos squared x plus that times 2 is 2 sine x cos x. And what do we know 2 sine x cos x is? sine 2x plus sine squared x. Now if you can't do that binomial square story, no problem. You write the binomial out twice and you multiply the thing out. Minus 1 over denominator, we can multiply the first and the last because that's the conjugate pair. Okay? So it's going to become cos squared x minus sine squared x. Again, if you don't identify with those things, you just multiply the brackets up. Okay? People, what is cos squared x plus sine squared x equal to? Is equal to 1. So that will cancel with minus 1. Not so? So 2 sine x cos x can be written as what? Sine 2x over cos squared x minus sine squared x? Cos squared x. Cos 2x, which is tan 2x. So in this case, we didn't have to work with the right hand side. Okay. Any questions here? Huh? No. Number 2. 2.1. Prove the identities using compound angles and double angle identities. Which side are we going to work with? Okay, we're going to go to the left hand side. Okay. So, here we're using the sine double compound angle. Can you see that, people? So this can be sine of alpha plus beta. Can be written as sine of alpha cos of beta plus sine of beta cos of alpha. Okay. So sine of alpha is going to be sine of x cos of y plus sine of y cos of x. And that is all over cos of x cos of y. Not so? But we know we can write each denominator of its own. If you got 2 plus 4 over 2, we know we can write this as 2 over 2 plus 4 over 2. You can break it up as 1 plus 2, which is 3. Not so? Instead of saying 6 over 2, which is 3. You all agree with that? So I can put each term over its own denominator. Not so? So I'm going to apply that here. So it becomes cos x cos y cos x cos y. Why do I do that? So that I can cancel out. Okay, you can cancel out here. And what cancels? In the first term is cos y. So sine x over cos x is going to be tan x plus cos x over cos x cancel. So it's going to be sine y over cos y, which is tan, which is also equal to the right hand side. Any issues here? No? You won't have issues because you didn't do the work. No? (2.3) Prove the identities. Okay, you read that already. Which side is more complex? Which side are you going to work with? Left hand side. So this is again sine alpha plus beta will be equal to sine alpha cos beta plus sine beta cos alpha, or cos alpha sine beta. If that is minus, this has to go minus. Okay. So sine 45 plus x. So it's going to be sine alpha plus beta, so it's going to be sine 45 cos x plus cos 45 sine x. And that is being multiplied by, so that will be sine 45 cos x minus sine 45 sine x cos 45. So sine 45, cos 45, that comes from the special triangle, the 45-degree triangle. So it's 1, 1 root 2. So this here would be 1 over root 2 cos x plus 1 over root 2 sine x into 1 over root 2 cos x minus 1 over root 2 sine x. Or sine x times root 1 over root 2, which is exactly that. Okay? Now as you can see, we have the conjugate pair, which will lead into difference of two squares as an answer. So I can multiply the first and the last. What is 1 over root 2 times 1 over root 2? It's 1 over 2. Cos x times cos x, cos squared x, minus 1 over root 2 times 1 over root 2, 1 over 2. Sin x times sin x, sin squared x. So what do we notice? We only have sines. So we can replace cos squared with 1 minus sine squared. So it's 1 into 1 minus sine squared x minus a half sine squared x. So we multiply that in. So it will be a half minus a half sine squared x minus a half sine squared x. And as you can see, you got like terms there. So you will get a half minus half is negative 1 sine squared x, which is equal to the right hand side. Something like this is worth 1, 2, 3, 4, 5 marks. 5 or 6 marks. Or something like this, okay? But you guys don't want it. We have 3 left. Let's do the first one of the 3. Of course, the left hand side we're going to work with. Not so. You see this 10 here? The 10 can be written as what? 6 and 4. Why 6 and 4? Because I see here's the 6 and the 4. Okay. So it becomes 2 cos 6x cos 4x minus the cos 10x can be written as cos 6x plus 4x. 6 plus 4 is 10, not so? So that's going to use the cos expansion. Cos of alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta. So in this case it will be cos 6x cos 4x minus sine 6x sine 4x. Okay? Plus 2 sine squared x. We'll come back to that. We won't change that unless we need to change it. Okay? So you're going to multiply and get rid of this bracket here. So I will have 2 cos 6x cos 4x minus cos 6x cos 4x minus, plus sine 6x, thank you, sine 4x plus 2 sine squared x. Of course those are like terms. Becomes cos 6x cos 4x plus sine 6x sine 4x plus 2 sine squared x. So what does this now remind us of? Cos expansion. But if this is plus, then this is minus. So my alpha angle is 6x and my beta angle is 4x. So it's going to become cos 6x minus 4x plus 2 sine squared x. So what is cos 6x minus 4x? Cos 2x. Not so? So that's going to become cos of 2x plus 2 sine squared x. So which one of the 3 you think we're going to use here? 1 minus 2 sine squared x plus 2 sine squared x. Cancel. That will then give you equal to 1, which is then in turn equal to the right hand side. Okay? Repeating? Sleeping? No. Making like you sleep? No. Okay. Just look like you. Out of it. Are you all okay with this? Alright? Uh, 2.7. 2.7. This is very similar to 2.1. I'm not going to spend time on that stuff. Carry on with our lives. The same idea is being tested in that question. Okay? .9. Which side are we going to work with here? We're going to work the left hand side. Okay? Could have multiplied first out and see what you're going to get, but it's fine. But you see a sine, cos, sine, cos, sine, cos, sine, cos, sine. So we know we're going to work with this here, this one. Why? Because that's going to form a trinomial, and then you're going to factorize the trinomial. Okay. So we see the left hand side. So cos 2x is going to become cos squared x minus sine squared x. That is going to give you positive 2 into 2 sine x cos x. Now this 2 here, you write it as plus 2 into sine squared x plus cos squared x. Otherwise we're not going to get a trinomial. Okay. So that's going to give us cos squared x minus sine squared x plus 4 sine x cos x plus 2 sine squared x cos x and sine squared x plus 2 cos squared x. So cos squared x plus 2 cos squared x is 3 cos squared x. Why am I not writing sine first? Because if you look at the brackets, cos is first. Plus 4 sine x cos x plus 2 sine squared x. Now this should remind you of a trinomial. If you don't see the trinomial, replace a cos with a y. So 3y squared plus 4xy plus 2y x squared. You see the trinomial now? Yes, it factorizes into no, made a mistake. Sorry? On this line here? Where? This one here? Oh, I didn't subtract that. So this is supposed to give you 1. No? Yes, there we go. There's my mistake. Thank you. So that would simply give us 3y and y, x and x are both plus. Okay? But y is a cos, so it's going to be 3 cos x plus sine x into cos x plus sine x, which is exactly what I have on the right hand side. But if you can see the trinomial without rewriting it as I did there, no problem. Okay, you don't get extra marks and won't be penalized if you don't do it like that. Okay, I think that's the end of it, not so? So I don't need to delete it. Okay, so today we need to look at general solution. Okay, homework before I forget. The homework is the even numbers of exercise 5. Solving equations and determining the general solution. I think that's the last part, and this is also coming in your upcoming exam, okay? Yeah, what do you think? We're looking at worked example 1. And this on page 103. The question says solve the equation and determine the general solution. Solve the equation and determine the general solution. Okay. So this question here in particular has a restricted domain. Okay. So this one you don't have to find the general solution. Okay. But from grade 11, if you are given the restricted domain, we work out the general solution first, and from there we determine. Okay. As I said before, you don't have to do it like that. But the reason why I do it that way is so that you can practice the general solution at the same time. That's the reason why I do it, okay? But as I said, it's not a must that it must be done. Okay. So let's do this. We're going to determine the general solution first of 3 cos x minus 25 plus 2 is equal to 0. Alright. So what's the first thing we need to do? Take the 2 over. So it becomes 3 cos x minus 25 is equal to negative 2. What do we do there? Divide by 3, both sides. So I got cos into x minus 25 is equal to negative 2 over 3. What do I do now? What do I do now? Reference angle. As we did before in grade 11. Our reference, x minus 25. Remember, I don't take the negative into account. So I say op cos 2 over 3.
Please. Aaron Finch, can you come down to the office, please? Aaron Finch, can you come down to the office now? The following girls, can you please come down to the office during register? Sipegwe, Ikono Kama, Tandeka Lata, Zia Famak, Zoe Jacobs, Setu Mabacha. Can you come down to the office during register, please?
Right, cos is negative in quadrant 2. How do we get in quadrant 2? So x minus 25 equals 180 minus 48,12 plus k times 360. So we take that over the equal sign, so x is equal to 180 minus 48.12 plus 25. That gives us an angle of 156,88. 156,88 plus k times 360 degrees. Or in quadrant 3, cos is negative in that quadrant as well, quadrant 3. X minus 25 equals 180 plus 45,12 plus k times 360. Why k times 360? Because the period of the cos graph is 360. Yes? Sorry? Why am I adding? Adding what? Cos is negative in that quadrant and this quadrant. So in this quadrant is 180 minus, in that quadrant is 180 plus. Not so? So that is going to be 180 plus 48,12 plus 25. That gives me an angle of 253,12. 253,12 plus k times 360. Now if this had to be general solution, I'll stop here and add k as an element of integers. Okay. It's going to be a good practice to write it down anyway. So you just say k is an element of integers by one of the two. But remember, this was a restricted domain between those values there. From x is greater than or equal to negative 360, but less than or equal to 360. So we start listing. We say x is an element of, then we put 0 through here. I'm going to get 156, 8, 8. If I put another, if I say 156, 156 comma 88 plus 1 times 360, that is 516 comma 88, which is outside 360. Can you see that? Just close it. That's outside 360, which is outside the given domain there. Okay? So I'm not going to list that one. So I'll have replaced that k then with is a minus 1, which then gives me negative 203, negative 203 comma 12. Okay. If I'm going to put minus 2 in here, what do you notice? What do you think is going to happen? So it can be outside. So I don't write that down. Okay. Then on the other branch, so we depleted that branch, we're going to the next one, it's 253, 12. If we put 0 through there, put 0 through here, I'm going to get 253, 12, which is definitely inside. What's going to happen if I put 1 in there for k? It's going to be outside the given restriction, not so. So what do I do is I then put minus 1. If 1 was within, then I would have put 2, then 3 and so on until it doesn't satisfy it anymore. So it's negative 106, comma 88. If I'm going to put negative 2 in, what's going to happen? It's going to be on the outside again. You understand? So that is where we stop. And a sum like this is worth a minimum of 6 marks as it stands. You must get a sum like this in your final exam as well. For homework. Do the even numbers. We need to do the examples as well. Exercise 5, the even numbers. We didn't do enough work in order to tackle exercise 6 here. Okay. People enjoy this every day. Good afternoon, class. Please do your homework assignment, especially the science.